So what I was going to do, or what I'm going to do, is just present about 20 pictures as a sort of photo gallery slideshow of some LED projects that I've worked on recently, and just give a brief summary of what they are and what I've learned. But the control of it is going to be a little bit weird because I'm having to remote control a web browser on Richard's PC. So getting started with LEDs, there's a lot of sort of standard projects where you just stick an LED on the output of some other project, like this board here, and you're just using it as an indicator, as an indicator to show that an output is on or off. And you'd use that maybe as just a stepping stone to a more interesting project. So if you look at, for example, any of Tony's projects, he's controlling actuators and machinery and stuff. Okay, let me try and move to the next one. Here we go. So what happened though was I started getting into producing more artsy LED stuff. And this is the first project, or the second project actually, that I did, which was to buy a kit from Adafruit, which was a costume goggles kit. So they give you a set of plastic goggles, some NeoPixel rings to go inside the goggles, and a little controller, which is Arduino compatible, but it's a very small one, and a little battery and a little charger. So basically everything you need to get started. And Adafruit stuff works really well, so it was pretty good fun. Here's a couple of animations of patterns that I made working on this. So this was, I wouldn't recommend the platform at all to anyone getting started now, but at the time it's the smallest Arduino board that you can get. It's got something like 5 kilobytes of programmed ROM available and 200 bytes of RAM or something like that. And I really enjoyed trying to squeeze in as many different patterns onto this thing as I could in C, really trying to make my code compact and small. So I guess the big thing for this was even the Arduino random number generator, which I was using to pick colors, is too small. So too big. So I wrote my own random number generator on the basis that I didn't mind it being a bit smaller, as long as I didn't mind it being a worse random number generator because I'm just picking random colors, as long as it was a little bit smaller in RAM. And if we come down to the next picture, there's a bit more context. There's me wearing goggles running that mode in the animation above on a SantaCon 2017, when we organized a parade of many, many people dressed as Santa. And this was in the Daily Mail, or on the Daily Mail website, which was a dubious claim to fame. So wearable stuff seemed cool. So I built another wearable project here. It's a t-shirt with a 5x5 NeoPixel grid, which are their individual pixels, which are sewn on individually, and they're connected by conductive copper thread. So even the tracks between them are sewn on. And what I did was I put some controllers on my wrists, and you could play a snake game on this. The microcontroller that's controlling it is a BBC microbit. So this is what it looks like inside. So there's the microbit. There's some dodgy power supply, and all of these dotted lines are conductive cable. So you're basically sewing your circuits like on a PCB, which was quite awkward because you can't cross them. You can't ever cross the cables because they're conductive. But somehow I managed to get it to work. That was in Python, which is one of the big languages that Microbit uses. I was pretty disappointed to discover after I'd written one game, the snake game, that Python is really, really memory heavy on the Microbit. So I couldn't fit any more games in. I had this vision of having 3 or 4 games available for people to play. Nevertheless, it was really good fun. I wore it to Halloween a couple of years. People seem to like it. And the next wearable project that I did is here for Holly. She did not like this at all. So it's a doggy harness with a rainbow. It's a dot star strip with rainbow patterns on. If you can see at the bottom, there's the battery pack hanging off. And every time she walked, her foot would tap the battery pack and then she would stop. And then sometimes she could only walk in a circle because she wouldn't move that foot and whatever. So it looked cool, but it was not a particularly, it was a somewhat cruel thing to attach to her. So we stopped putting it on her. But yeah, it could have been nice. See what's coming up next. Oh yeah. So then last year I got into making lamps. This is one I made for my mum. It doesn't have any controllers in it. It's just a big on-off, really nice feeling rocker on-off switch in the lid there, and about 8 LEDs and a USB socket to provide power. And so it's just a Marmite nightlight.
Ben, I've got to ask, sorry, did she like it or hate it?
She loves it. That's specifically why I made this for her. Yeah, she was really pleased with it.
There is meaning behind that question for those that are not aware.
Yeah. So there's no microcontrollers in here at all. It's literally just on or off. And so it's LEDs, a few resistors, switch and a USB socket sort of squished into the lid, and then it all screws on and the jar glows a little bit more when these LEDs are inside the jar. The next lamp I made, this one, a Corona lamp for Corona times. This one's got 3 colors of LEDs in it, white, red, and the other one I think is yellow. I couldn't quite remember today. And those are controlled by PWM to be different brightnesses. So like in the last talk, there's a strip of LEDs that the controller could go from fully off to fully on or anywhere in between. The way that this lamp works is that control is available for the red, the yellow, and the white independently. And then up where the bottle cap normally would be, there was a dial. And so you could have it off, you could have it dim red, and as you turned it, it got brighter and whiter. So the same kind of color sequence you get if you put metal, if you heat metal, it goes from dim red to bright white. And that does have a microcontroller. So that uses an 80Tiny85, which costs about £1 if you buy just one of them. That's the same microcontroller that was driving the LEDs in the goggles. So it's a controller that I really quite like using because it's cheap. So when I blow it up, I can just put another one in. And I learned Rust, the Rust programming language I've been using on PCs, but there's been a movement to try and get it working on microcontrollers. So I thought, all right, fine, I'll try out Rust on this lamp. So it feels a little bit over-engineered, maybe, but not too much, because it turns out a lot of modern camping torches also use exactly this kind of microcontroller in their on-off switches as well. All right, what's next? Oh yeah, the final lamp is this. It's the scary, evil red face. So this is a mask of my face with the circuitry again is just not even an on-off switch. You connect power to it. The circuit I built for this, that was my learning experience, was making it constant current. So if you're driving an LED and you know you're going to have 5 volts, you can calculate a resistor to put in series with the LED, and that will make sure that the LED has the right amount of current. But if you lower or raise the voltage, then the LED gets dimmer or brighter, and because it doesn't have the right operating parameters. So there's a little circuit you can build with 2 transistors And I built that on the same day that we made this mask. So I thought I'll stick them together. And I liked how it looked. It was stuck up on my wall. That dog, Holly, earlier on, would not sleep in the same room as this mask once we put it up. She woke up in the night and was howling. So we had to let her sleep in a different room. And in the next slide, the physical construction is, this is my face being molded with like strips of bandage, plaster of Paris bandage that my friend put on my face and then let dry and then take off to make the mask. Because we were both trying to do lockdown hobbies at the same time and trying to find ways to integrate them. All right. Next up is, oh yeah, this one I really enjoyed it. I struggled to get a good photograph of it. I don't have it with me now, so I couldn't make a new video of it or anything. But it was more a technical project than a looking pretty project. And that is, there's the microcontroller. Hopefully you can see the little black square. It's got 8 pins, 4 on each side. 5 of those pins are GPIO. And I wanted to see if I could multiplex them so that 8 LEDs, 1, 2, 3, 4, 5, 6, 7, 8, 8 LEDs could be driven by those 5 GPIO pins, and also be driven using PWM, so that the software running on that chip can control the level of each of the 8 LEDs independently of the others. So it kind of looks like a cool little pulsy star when it's running. The construction is pretty shoddy because I was more interested in getting the software working than doing an end product. And that was probably written in either C or Rust. Okay, more recently, the thing I've been having fun with this year is this, which is a string of NeoPixels that kind of look like fairy lights. There's 50 on a string, and I've been making various boards and programs to do interesting stuff with this. So there's a couple of people I've made these for and given them away as gifts. I'll show you the board in a bit. It's just the string of LEDs. It's got a rotary encoder dial, the same as the Corona lamp, and you can swizzle it to switch between various different pulsing patterns, or you can switch it into a static pattern. And turns out that's simple enough for me to just keep building them and handing over to people as presents, and costs maybe 20 pounds to build a new one. So that's like my main product at the moment that I keep making. Yeah. If you take that string and the same software and you put it in a jam jar, it kind of has this different 3D feel. So it looks and feels very different when it's in a room. It feels much like it has depth because it's got 3 dimensions. That jar's just an old jam jar that I thought looked nice. But it's running the same software. The software is written in Python. It's running on a PyPico, which you can see here. So the PyPico had just come out when I started playing with these things properly, and so it seemed like an obvious thing to try and make work. There's a PyPico underneath, and I've soldered this board on top, which is SparkFun snappable prototyping board. So you buy this board and you just snap the board on the tracks you want so that it ends up exactly the dimensions you want. So power comes in one end, on-off switch. There's a diode that feeds that power down into the PyPico if you want. There's the rotary encoder, and then the LEDs connect on the end. But I made a few of these, and then I started getting bored with all that soldering. So I bothered learning how to do circuit board design a little bit. So I was excited to actually get KiCad working enough to build a circuit board, even though there's really nothing going on this board. There's basically power lines going between various components, and then linking some of the bits to GPIO pins. It's really not a complicated board at all. So I designed that in KiCad, and then maybe Aisler, I think they're called, in the Netherlands, printed it for me. So it's a minimum order of 3. So I've got 3 of these now, and it just fits very nicely on top of the Pico. And I can just make them and give them to people, and make another one and give it to someone else. The other thing I've done with those is another thing I made for some friends of mine, is put that spiral. This is my friend Jess. This is her living room. I put that exact same strip up on their wall in a spiral, so that you have this 2-dimensional effect. So if I scroll down a bit, maybe you can see the 2D-ness of it. Instead of it being a long linear line, you can now write code that understands the maths of circles and spirals, and is able to understand that an LED is near another LED, even though it's much further down the NeoPixel string, because it's come around the loop again. So I love this. It's like being in a disco. But unfortunately, I've not lived in a flat with a suitable wall until this week. I've just moved flats, so I should have this up next week, back in my flat again. Yeah, so this was written in Python as well. This is the first one I've shown that is running on a Raspberry Pi. It's running on a Pi 0W. The 2 friends of mine can control the patterns from their mobile phones. That's the big advantage for running on a big Pi rather than on a Pi Pico, is it's got Wi-Fi and can just run a normal web server. So they basically get a web page on their phones to make it do stuff. And then the last big project, by far the most technically complicated one, is this LED bike wheel setup. I'll show you what it looks like down here first. So it's a persistence of vision bike wheel. As the bike wheel spins, it displays a pattern like this, for example. There's a lot of different patterns. And the way it's implemented is up here. One of the bicycle spokes has got a strip of dot star LEDs. So there are 23 LEDs along one of the spokes. And then as the wheel turns, you get a persistence of vision effect. So there's a Pi 0W in there as well. So I'm running Linux inside my bike wheel. There's big battery pack and a little charger on there as well, and also a magnet sensor that senses a magnet that's stuck to the bike frame. So everything is contained within the bike wheel. And so this is physically the most challenging project I've done by far. It's outside because it's in my bike, with me riding around. It's not just in someone's living room. Every time it rains, it gets a bit wet and malfunctions. So I really need to figure out better packaging for this at the moment. The software is really hard because the bike wheel spins at the speed that I'm riding the bike. So the program doesn't get any say in how fast it can process stuff. And even just getting the LEDs updated fast enough was a big challenge. So if I'm riding normally, this wheel might spin 3 times a second, which doesn't sound very fast, but it's got to render. It's got to change it's got to change the LED strip enough that, say I want to have 200 pixels around here times 300 times three times a second, you're getting to 500, 1,000 updates a second of the entire LED strip, which includes computing the next pattern, getting that sent out over the SPI bus into the dot star LEDs. And so I originally wrote this in Python, absolutely not fast enough. I rewrote it in Rust, still wasn't fast enough. I ended up digging around, playing with all kinds of lower level libraries, I discovered that the level shift that I was using couldn't level shift at the speed that I needed to be level shifting. So I just chopped that circuit out completely, because it turns out the dot star LEDs with this really short cable length will work fine from 3.3 volts. Yeah, so this is a frustrating project to me, because it looks great. I ride it round, but it breaks the whole time. I'm not confident at the packaging. I really need to do something. And it's not very amenable to just buying a box, because it's got to fit inside that 20-inch bike wheel. Yeah. So the last picture at the bottom is my friend took a nice time-lapse picture of the bike wheel, displaying a rainbow pattern as it spins. And because that's probably a 1 or 2 second exposure, I am completely blurred out. Yeah. So that's what I've been up to LED wise. I will take questions if anyone has questions.
Awesome stuff.
Yeah, cool. No questions.
What's your next LED project?
What's my next one? What I'm gonna do is put that spiral back up on the wall, and then I will get totally absorbed into designing new patterns for that, I think, at the moment.
I was thinking, if you wanted to do different patterns than a spiral, but didn't necessarily want to program in all the different positions of each LED, one thing, if you had a very large number of LEDs, or you wanted to do this often, this might be worth it. You could have you could simply set all the LEDs to a unique color, then take a photo in a dark room, and then write a Python script that automatically stripped out the positions of every LED. And then
I almost did that for the spiral one, and then I thought I'll just try it with some very rough maths to see what it looks like. So I was all prepared to basically do that. And then it turned out that, at least for the spiral, I didn't need to, because that positioning is good enough. And then when the jar project came around, I thought about doing it for the 3D jar as well. And then I didn't. But I think it keeps coming up in my head enough that inevitably I will do exactly that at some point. Yeah.
I think there was a video by a chap called Matt Parker.
Yeah, Matt Parker's Christmas tree.
That's it.
Yeah. Yeah, he's doing that.
What does Matt Parker? I know Matt Parker. Does he do what I just said, or what you were doing?
He has he was turning the LEDs on and off and using a video camera. So it was a little bit more dynamic.
And I think he spun the tree round in 3D to be able to map the location of each LED.
Yeah. And then a little bit of manual fix up at the end.
You've got a link to the video. I'll take that in the chat.
Probably Googling Matt Parker Christmas tree will find it.
Ben, you were saying about wanting a waterproof housing.
Say again?
You were saying about wanting a waterproof housing for the bike wheel.
Yeah.
Tent windows are made out of fairly heavy grade clear PVC, which you can buy separately from hardware stores.
Yeah.
And I used to make waterproof camera housings by simply molding around the camera and then evacuating with a straw and ironing it closed on an ironing board.
Oh, and
you could probably do the same with just the charger port showing.
Yeah, that makes sense. Like, I've used PVC, I've used Ziploc bags a bit before, just as really temporary structures. So yeah, I think it sounds like that tent window kind of stuff would be, that would be interesting to try. Like, really, my skills are very good at software, medium at hardware, and then absolutely awful at anything packaging related. So
I do like I like Tony's idea of using PVC pipe.
Yeah.
Go to the plumbing store and buy some PVC pipe.
Yeah.
A couple of people have asked in the chat what the Netherlands PCB manufacturer was.
Oh yeah. Hold on. It's Azela.net. I'll post it into the chat for the spelling. Hold on.
I order quite a lot of waterproof housings from CPC Farnell, which I guess a lot of people on this call probably do as well.
Yeah.
They've got quite a good selection.
Yeah. The problem really is the really weird, awkward shape of the inside of the bike wheel, and I don't really want to be taking off spokes to get stuff out and putting stuff in, which really massively constrains. Like I could imagine if I knew what I was doing, I would just 3D print something that fits around the hub, take all the spokes off, fit the electronics around the hub in a beautiful circular 3D printed thing, and then put all the spokes back in. But I really don't want to do that to my bike.
Can I just ask, that strip that you've got, the fairy light strip, could you post the link to that as well? Because as I said, I'm also doing LEDs all over the place, and I'm quite intrigued by that. Is it waterproof, by the way?
No, it's from Adafruit. They also do a waterproof one, which I've considered buying.
Okay.
Just because I just got a balcony in my new apartment today as well, so that may encourage me to buy something waterproof. I'm just looking for that URL for you. Hold on a sec. Here. It's Adafruit 4560. Chat. Here we go. The Adafruit 4560 is the NeoPixel.
Right. Thanks.
Yeah.
And those dot star ones, you can cut them as you want.
Yeah, dot star, and well, yeah, whether they're dot star or NeoPixel, you can cut them anywhere. Protocol wise, you can cut them anywhere. Hardware manufacturer wise, like on the bike, for example, I've cut the strip, but it's a little bit exposed to the environment, more than I would like it to be, but there's no protocol electrical problem with that. Yeah, so I managed to blow up the first LED on one of the NeoPixel fairy light strings. I managed to blow up the first LED on one of those. So one of my friends has a different version with 49 pixels, not 50 pixels.
Easily done.
Yeah.
I think I brought one out. It's just a soldering issue.
Yeah.
You mentioned that when you hang something off your dog's collar, sometimes it walks in a circle if it's hanging left or right.
Yeah.
Have you considered building a collar so that you can move the tag, so you have a remote controlled dog?
I have considered that.
Because there's a product to market.
It seemed very mean. This poor dog was traumatized enough. Yeah.